Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind adjust the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
My first introduction to algebra was in mid-1964 in the 5th grade in Agbor in the Midwestern Region of Nigeria. My first algebra textbook was written by an English schoolmaster named Clement Vavasor, C.V. Durell, who invented the quadratic equation of algebra. The quadratic equation is one of the most important contributions to mathematics that was made by Africans and made in Africa. The quadratic equation was first solved in the Berlin Papyrus. The Berlin Papyrus was excavated in Africa, but renamed after Berlin, Germany. In the history of mathematics, it was the tradition to credit the mathematical knowledge that was developed in Africa to Europe. Following that tradition of historians of mathematics, the Berlin Papyrus was credited to the city of Berlin, Germany, and not named after the city in Africa that the papyrus was excavated from. The quote-unquote Berlin Papyrus was written in Africa and written by Africans and written between 3,720 years ago and 4,108 years ago. In that African papyrus that was written 4,000 years ago, the quadratic equation was stated as x squared plus y squared equals 100 and y equals 3/4 divided by the product of 4 and x. The quadratic equation of algebra that is in the homework assignment of a 12-year-old contains at least one unknown variable that is squared. That unknown variable is often called x. The 24 million system of partial difference equations of algebra that I solved on the 4th of July 1989 and solved across a new internet, that is a new global network of 65,536 tightly coupled commonly available processors that made the news headlines, contained 24 million unknown variables. That was a world record in algebra. In my 4th of July 1989 invention, I computed across a new internet. I visualized my new internet as my new global network of 65,536 tightly coupled processors, with each processor operating its own operating system, and with each processor having its own dedicated memory that shared nothing with each other. Each processor within my new internet had 131,072 bytes of memory that I used for the integer and logical operations that arose from my algebraic computations. I also used 2,048 floating point coprocessors. I used those coprocessors to execute my floating point arithmetical computations. Each coprocessor had 4 megabytes of memory. The frontier of extreme scale algebra is far beyond the quadratic equation that contains 2 unknown variables that was first solved 4,000 years ago in Africa. Extreme scale algebra arises during the general circulation modeling that must be used to foresee otherwise unforeseeable global warmings. Extreme scale algebra is used to discover and recover otherwise elusive crude oil and natural gas. Extreme scale algebra is used to solve the toughest problems arising in computational physics. The most important quest in algebra was to theoretically and experimentally invent how to solve extreme scale tridiagonal system of equations of algebra and how to solve those equations across millions upon millions of tightly coupled processors, with each processor operating its own operating system, and with each processor having its own dedicated memory that shared nothing with each other. One reason I was the cover stories of mathematics publications was because I mathematically discovered that it's impossible to reduce a tridiagonal system of equations of algebra and reduce it to a mathematically equivalent diagonal system of equations of algebra. I de facto circumvented that impossibility by taking 2 steps backward and to the granite core of the physical problem that is mathematically modeled, namely the extreme scale petroleum reservoir simulation that was governed by a tridiagonal system of equations of algebra that arose from discretizing a system of partial differential equations of modern calculus and arose from approximating that system by a companion system of partial difference equations of a new algebra. It was at that granite core of the most excruciatingly detailed petroleum reservoir simulation that I reformulated the partial differential equations. That is a new calculus that was not in any calculus textbook that was printed in the 1970s or earlier. The reason my contributions to mathematics was the cover story of the top mathematics publication, namely the May 1990 issue of the Siam News of the Society of Industrial and Applied Mathematics, was that I created a new calculus, and I did so by inventing 36 additional partial derivative terms of calculus. In the old calculus that is used to recover otherwise unrecoverable crude oil and natural gas, only 45 partial derivative terms represented the second law of motion of physics that was encoded into the 3-phased crude oil, injected water, and natural gas extreme scaled petroleum reservoir simulator. My contributions to the body of mathematical knowledge called calculus and algebra are these. I added the 36 partial derivative terms of modern calculus that I invented to the 45 partial derivative terms that prior research mathematicians invented. And I did so to bring the total partial derivative terms to 81. In the advanced calculus textbooks and in the old paradigm of extreme scale algebraic computations arising from petroleum reservoir simulations, the governing system of coupled nonlinear, time-dependent, and state-of-the-art partial differential equations of modern mathematics was parabolic instead of hyperbolic. In my new paradigm of extreme scale algebraic computations that enabled me to massively parallel process and to process across a new internet that I visualized as a new global network of 65,536 tightly coupled commonly available processors that shared nothing with each other. And in that new paradigm, my system of coupled nonlinear, time-dependent, and state-of-the-art partial differential equations of modern calculus is hyperbolic, not parabolic as written in calculus textbooks. My contributions to calculus was a paradigm shift because such governing partial differential equations are described in all the textbooks as parabolic instead of hyperbolic. They are described in calculus textbooks on the multi-phase and multi-physics porous media flow of crude oil, injected water, and natural gas, such as the crude oil and natural gas flowing from the water injection wells to the crude oil and natural gas across the oil fields of the Niger Delta region of southeastern Nigeria.
Insightful and brilliant lecture.